In this video, we're going to see that absolute value equations can have 0, 1, or 2 solutions. And before we work some examples, let's just think about it graphically, why that is the case. So that's my x-axis, that's my y-axis, and let's say I had the graph of y is equal to something, I'll just call that a, times x minus something else, let's just call that b, plus something else. This is the general, or this you could view this as the general absolute value equation. Well, this will have a graph something like this. I'm just going to draw it very roughly. It's going to have this type of shape. It could also be downward pointing if a right over here were negative. But a graph like this, it obviously would keep going. If you said, when does this expression on the right equal 0? Or another way of thinking about it, for what x values does y equal 0? So y equals 0 is right over here. And you could see from this graph that y is never equal to 0. So there's no x values that would make this left hand equal 0. So in that situation, you would have 0 solutions if you had 0 is equal to all of this stuff right over here. Now let's say that this value right over here is when y is equal to 2. So if you had 2 is equal to all of this stuff right over here, well, you would have exactly one x value that makes that true. Now let's say this over here is 5. So if you had the equation 5 is equal to all of this business, well, there would be 2 x values that make that true. So depending on the equation, you're going to have 0, 1, or 2 solutions. Now let's do some examples algebraically to see that happening. So let's say I had the equation negative 4 is equal to negative 5 times the absolute value of x minus 3, and then all of that plus 2. Pause this video and try to solve this absolute value equation. All right, now let's do this together. So what I try to do is isolate the absolute value part, the way that you would manipulate any algebraic equation. So we can start off by subtracting 2 from both sides so that we get rid of that plus 2 over there. And we are going to get negative 4 minus 2 is negative 6 is equal to negative 5 times the absolute value of x minus 3, and then that's gone right over there. Now let's divide both sides of this equation by negative 5. So divide by negative 5, divide by negative 5. And of course, we're going to get 6/5 is equal to the absolute value of x minus 3. Now this is where it gets a little bit interesting. If the absolute value of something is equal to 6/5, that means that something, that x minus 3, could be equal to 6/5. But it also means that x minus 3 could be equal to negative 6/5. How do I know that? Well, if x minus 3 is equal to negative 6/5, you take the absolute value of that, you get 6/5. If it's equal to 6/5 and you take the absolute value of that, well, then you're going to get 6/5 again. So these are two possible solutions. So let's solve it. So if we add 3 to both sides of this equation, we're going to get x is equal to 3 plus 6/5. If you add 3 to both sides of this equation, you get x is equal to 3 minus 6/5. So 3 is the same thing as 15 over 5. 15 over 5 plus 6 over 5 is equal to 21/5 in this situation. And over here, this is equal to 15 over 5 minus 6 over 5, which is equal to 9 over 5. So here, we clearly had 2 solutions. It was kind of like this scenario right over here. 2 x values gave us that y value. Let's look at 2 more examples. So let's say that I had the equation 6 minus the absolute value of 2x plus 3 is equal to 6. Pause this video and see if you can solve this. All right, once again, let's try to isolate the absolute value. Let's subtract 6 from both sides. And we are going to get, on the left-hand side, we're just going to have negative absolute value of 2x plus 3 is going to be equal to 0. Well, we can multiply both sides by negative 1, or divide both sides by negative 1, and you're going to get the absolute value of 2x plus 3 is still going to be equal to 0. And so that means that 2x plus 3 could be equal to 0 And that's it. Because if it's not like there's a positive version of 0 and a negative version of 0. There's just 0. If the absolute value of something is 0, well, that thing inside the absolute value sign must be equal to 0. And then you just solve from here. If you subtract 3 from both sides, we get 2x is equal to negative 3. Divide both sides by 2, and we get x is equal to negative 3/2. And here we had one solution. And a good hint is that when we isolated the absolute value sign here, on the right-hand side you got a 0. If on the right-hand side you got a positive number, you'd have two solutions. If on the right-hand side you get a 0, you're going to have one solution. And as we're about to see, if on the right-hand side, when you isolate the absolute value, you get a negative value, well, it's impossible to take the absolute value of something and get a negative value, and then you would have no solutions. But let's look at an example of that. And I'm going to do this in purple, just for the sake of variety. So let's say I have 3 times the absolute value of negative 4x plus 7 is equal to 1. Well, let's subtract 7 from both sides, and we are going to get 3 times the absolute value of negative 4x is equal to negative 6. Let's divide both sides by 3. And we are going to get the absolute value of negative 4x is equal to negative 2. Well, how can I take the absolute value of anything and get a negative 2? This is impossible. This will have no solution. So we've looked at all of the scenarios over here. 2 solutions, 1 solution, or no solutions.